Hello everyone, my name is Jack Sillin and I will be teaching you a little bit about fronts today. Fronts are very common weather phenomena that occur here in the US. They're responsible for the vast majority of the weather that we see and feel every day. Though many people don't know what they are, even though they're fairly commonly discussed, on TV weather reports and in the forecasts of both myself and others online. So, what is a front? A front is a boundary between two air masses. That's basically a front at its most basic form. So today I'll be talking about the two most basic types of fronts, and later I'll have a video on some more complicated types of fronts. So we're going to start with the warm front and the cold front. So those are the two basic types of fronts. So warm fronts are generally drawn something like this. They're a little semicircle with little semicircles on top. So that's a warm front. You may have seen that before. And a cold front has little triangles that extend along this way. So this fairly typical storm system, you'll be able to find a storm system that looks kind of like this, almost anywhere in the US and almost any time of the year. It's a very common type of storm. So let's talk about the warm front first. And fronts are not two-dimensional objects. Like anything in weather, our atmosphere is three-dimensional and weather is three-dimensional. So to look at the warm front in more detail, we're going to need to create a little bit of a cross-section. So let's do that. Cross-section from A to B. And we're going to recreate the cross-section down here. From A to B. All right, and our warm front is approximately halfway in between there. Now, again, what is a front? It's a boundary between two air masses. So on the A side, right, we have cold air. And how cold this air is depends on, the location and time of year. And then on the B side, we have warm air, right? So here's our warm air. Again, depends on the location and time of year, how warm that air is. Now, along the boundary, right, in a warm front, warm air is trying to kick out cold air from its position. So you're going to have warm air coming in, and it's going to hit this cold air, and because warm air is less dense than cold air, it will begin to rise. So it's going to rise up and along this frontal surface, right, which is, again, just a representation of the front with height. So, again, you're going to have cold air on this side of the front, and you're going to have warm air now being transported up and over the cold air on this side of the frontal surface. And then, obviously, as you get higher up, it gets cooler as you head into the upper atmosphere. Up here. So there it is, your little layer of warm air, and then your cold air and your cold air. Now, as the warm air rises, it cools and condenses, like all good air parcels do, and it will form rain clouds. But because the air is only rising gradually, it's not rising explosively, those rain clouds are not going to be very intense. It's going to be a classic rainy day, just steady, light to moderate rain. There could be some embedded heavier showers, but overall it's just going to be a pretty mild rain. It's not going to most likely feature those torrential downpours that you'll see with cold fronts. So that's a little bit of a tutorial on the warm front. Warm fronts move fairly slowly due to the fact that it's hard to kick cold air out. But usually eventually the warm front gets the job done. All right, so that's a little bit on the warm front. Now, what about the cold front? That's going to be our next topic of discussion. So cold front, basically the opposite happens of everything in the warm front. So instead of the warm air trying to kick the cold air out, well, the cold air is trying to kick the warm air out. So we're going to set up our same cross section from A, excuse my handwriting, from A to B here. And our cold front, again, located more or less halfway there. And then on the A side, you have your cold air. Again, just like last time. On the A side, you have your cold air, and on the B side, you have your warm air. But now the tables are turned. The cold air is trying to evict the warm air, and it is trying to do this at all levels, right? This cold air is sweeping in. And because cold air is heavier and denser, it can kick the warm air out fairly easily. If you think you have a big, heavy, guy walk in, and he can kick out the little light guy however easily he wants. That's a little analogy to think about a cold front. So because of this, the slope of a cold front is fairly steep. And when the cold air arrives and kicks out the little warm air parcels, they are forced to rise almost straight up, and often with a lot of force, since the big cold air is threatening to take over and is taking over. So as those air parcels rise explosively, they will often form into thunderstorms. Now, cold fronts are not the only things that can trigger thunderstorms, and they're not the only ingredient you need to have thunderstorm development, but they can play an important part. And many of the thunderstorms that we get, especially in the eastern parts of the U.S., are attributed to cold fronts. So that's a little bit on the warm front and a little bit on the cold front. And check back next time for more on the other two types of fronts, stationary fronts and occluded fronts, which can get a little bit more complicated. So hope you enjoyed this video and hope you learned something from this, and now you are better prepared to understand the weather reports that you see not only from me on weather.us, but also elsewhere in your daily lives. Thanks, and have a great day.